So your heart pumps blood essentially to two places. And the first place is your body. So you have your oxygenated blood on the left side, and we gotta remember that the lefts and the rights are switched because we're looking at the anatomical view of the heart. So it pumps it out to your body, and your body gets that oxygen. Your body uses it up and then circulates it back into the right side, where this time it's pumped out to the lungs and gets reoxygenated and gets that oxygen back, and then it's circulated back into the left side. And the amount of blood at any time pumped to your body is sort of based on this demand that your body has for blood. You can kind of think of it like you have this gauge that says, hey, I need this much blood to sustain this much activity. And this can change, so like if you start working out or something, your demands might go up. And your heart can accommodate for that and start pumping more blood to that body to meet those new demands. Heart failure describes this condition where the heart can't meet the demands of the body. So at any given time, the heart's not able to pump enough blood to meet the body's demands. And there are essentially two types of heart failure. The first one we call systolic heart failure. And systolic refers to systole, which is the phase of the cardiac cycle where blood is pumped out of the heart. And so systolic heart failure is when those heart muscles aren't pumping blood with enough force. So this often means that those muscles are weakened and smaller than with a healthy heart. And this typically makes it look quite a bit different. And when these smaller muscles contract, they don't squeeze as hard as they used to, and this causes less blood to be ejected with each contraction. Now I say contraction because the heart's this muscle, right? So when it contracts, it squeezes. You can kind of think of it like you have this water bottle that you're holding with your hand, and you squeeze the water bottle and it shoots the water out. It's the same concept with your heart. When those muscles contract, they squeeze the blood, and that's how you eject blood to both your body and your lungs. With systolic heart failure, since your heart muscles are smaller, think about squeezing that water bottle again, but just pinching it. It's going to be a lot harder to squeeze the water out, right? Well, it's the same thing for the heart with smaller and weaker muscles. It's going to be way harder for it to squeeze and pump that blood out to the body. You probably noticed that this heart has these sort of enlarged looking lower chambers, and at the same time it has this really thin muscle wall. And these are really characteristic traits of a heart with systolic failure. And these small muscles make it really hard for it to pump blood to the body. So that was the first type of heart failure. The second type is called diastolic heart failure. And instead of being a pumping problem with the muscles being too small, diastolic failure is a filling problem, which is why we call it diastolic failure, because it refers to diastole, which is that phase in the cardiac cycle where the heart fills with blood. So with this type of failure, your body's not receiving enough blood because your heart's not filling with enough blood to pump out in the first place. So if we jump back to that water bottle analogy, this time you're holding it with one hand, just like we were for the healthy heart, but instead the bottle's filled with less water. So even if you squeeze it with the same force as a healthy heart, less water is going to be ejected simply because there's less water in the bottle. And this is essentially what's happening with diastolic failure. Since there's less blood filling in the ventricles, even if it's pumping with the same force, less blood's going to be ejected to the body. But why is there less blood filling in the chambers? Well, it's because those muscles are actually larger in this case, and they take up more space. And this leaves less space for that blood to fill into the ventricles. Okay, so far we've shown both types of heart failure, and each time we've shown it happening on both sides. Well, this isn't always the case. It's definitely possible to have isolated heart failure, so maybe you only have it on the left side. Or you might have it only isolated to the right side. One important thing to note, though, is that usually a left-sided case happens first, and then that ends up leading to a right-side failure. I know I'm only showing systolic failure here, but I should note that this isolated failure can happen with either systolic or diastolic. So, depending on which side this is happening on, the left or the right, the symptoms are going to be a little different. Let's just go ahead and start with the left side first. So since the left side pumps blood out to the body, that means it's coming in from the lungs. And if it's not pumping it very efficiently to the body, that blood starts to get backed up into the lungs. Think of it like a traffic jam. What happens when they close a lane and then they only let one car through at a time? All those other cars get backed up. It's kind of the same thing. This blood gets backed up into the lungs because it's only pumping a little bit out at a time now. So a really common symptom of left-sided heart failure is fluid buildup in the lungs. This is called congestion, and it's also sometimes why we say congestive heart failure. Alright, so that was left-sided failure. Let's take a look at right-sided failure. Again, I'm just going to show systolic failure, but let's just note that this can happen with either systolic or diastolic. This time, since we know that the right side pumps blood to your lungs, we also know that it comes from the body. And since it doesn't pump blood as well to the lungs, we have that traffic jam situation again, but this time it gets backed up into the body. So patients with right-sided failure might start getting fluid buildup in their feet, legs, and abdomen. And again, just like the left side, you have congestion or fluid buildup, but this time it's in your body instead of your lungs. So as a quick recap, you could just have systolic failure on the right side, or you could just have systolic failure on the left side, and it's possible to have both. In the same way, you could have diastolic on the right side only, or you could have it only on the left side. Or you might have both. It's even possible to have a combination of systolic and diastolic failure. So now that we've kind of nailed those down, let's talk about this really important way that we measure the heart's ability to meet the demands of the body, and that's called cardiac output. Cardiac output represents the total amount of blood that the heart's able to pump every minute, usually given in liters of blood per minute. And a normal cardiac output is around 5 liters per minute. Now, cardiac output can be broken down into two other components, and the first is stroke volume, which is the amount of blood pumped out every beat, which is different than cardiac output because it's every beat, not every minute. And so we take this stroke volume and we multiply it by your heart rate, which is measured in beats per minute. And those two multiplied together equals your cardiac output. So if you were to change either stroke volume or heart rate, for example, let's say I lowered stroke volume, since cardiac output's dependent on these two variables, cardiac output's also going to go down. And that's what happens with heart failure. Cardiac output is lower because the heart's not pumping as much blood per minute. This is usually because there's a lowered stroke volume or a lowered amount of blood pumped out with each contraction. So usually heart failure is considered a secondary disease, meaning that it's caused by some kind of pre-existing or underlying disease that already affects cardiac output. Specifically, we're going to think about diseases that cause the death of cardiac muscle cells, which are also called cardiomyocytes. And when those muscle cells die, the heart gets weaker and it gets way worse at pumping blood. This lowers stroke volume and then it also lowers your cardiac output. And when the cardiac output goes down, the heart has two options to increase it again, based on our equation, that's stroke volume and heart rate. And your heart actually does that, and this is called compensation. So your heart compensates by either squeezing harder and increasing stroke volume, or beating faster and increasing heart rate. In the early stages of heart failure, these methods can actually help quite a bit in compensating for a decreased supply. But over time, those surviving muscle cells become overworked because they're constantly trying to either beat faster or squeeze harder. But to do either of those things, those cells need more oxygen. And since this is the whole issue with heart failure in the first place, a decreased supply of oxygen, those muscle cells won't receive the oxygen and more muscle cells tend to die off. And when more die off, stroke volume goes down even more. And this causes that whole cycle to repeat, which causes heart failure to get worse and